Okay, Algebra 1, lesson 3.4. We're continuing to solve our equations, okay? But this time we have a variable on both sides. Okay, so what we remember, right, is that when solving, you are being asked to find the value for your variable. Okay, and we're doing that by isolating the variable on one side using our inverse operations. Okay, so when your equation has a variable on both sides, what you need to do is collect all variables on the side that has the greater coefficient. And then once the variables are on the same side of your equation, you solve like you did prior to this. Okay, so this is just adding the fact that variables can be on both sides of our equation. Okay, so we are looking to solve 6x plus 22 equals negative 3x plus 31. Okay, so the difference now is that we have x on the left and on the right. Last week we had just something like this. Okay, so given that x is on both sides of your equation, we have a 6x here and a negative 3x. So 6 is bigger than negative 3. So we're going to take this negative 3x term and move it to the side with the 6x. Okay, so when you're moving a term, not just part of a term, right? We're taking this whole thing to the other side of your equal sign. Use the inverse, right? And the inverse of negative 3 is positive 3. So we're trying to cancel out this negative 3x from the right and just have it on the left. So negative 3x plus 3x, that's how it cancels. But what we do to one side, you're doing to the other side because we're keeping it in balance. So 6x plus 3x is 9x. You still have plus 22 equals 31. Okay, then like we did last week, we can say, okay, now we want x by itself. So we're taking x, multiplying it, then adding. So the adding we're going to undo first by subtraction, because that's the inverse, right? So we're subtracting 22 from both sides. When you subtract 22 from both sides, you get 22 minus 22, and it cancels. So you're left with your 9x on the left. Then on the right, you have 31 minus 22, which is 9. But we don't know what x is yet. We know what 9x is. So the operation we have is multiplication. The inverse of multiplication is division. So multiplying by 9, undo that by dividing by 9. Whatever you do to one side, you're going to do the other. So 9x divided by 9 is x, and 9 divided by 9 is 1. So we get x equals 1. Okay? All right, another example. 64 minus 12w equals 6w. Okay, this one is even a little more simple than the previous one because while you have a variable on both sides, on the right-hand side, you just have a term with a variable. So we're going to move this negative 12w over to the 6w. So it's negative 12. So we're going to add 12w to both sides. Okay, because we want this to cancel, so we want it to be the opposite. So you get 64 on the left, and 6 plus 12 is 18W. Okay, so we want this to be 1W, so it's 18 times W, so undo that by dividing by 18. That's how you get W, the 18s cancel. 64 divided by 18 doesn't go evenly, so we're just going to divide them both by 2. You don't need to make this an improper fraction, or a mixed number, I'm sorry. You can leave it as an improper fraction. Just make sure it's reduced, okay? So the first two examples that we have give you a solid answer for your variable, okay? It tells you this is what W is. The last one told us what X was, okay? Sometimes you're gonna have no solution, which means no matter what you pick for your variable, it's not gonna work. The left will not equal the right. Or you're gonna get a solution that is true for all values of X. Okay? When that happens, we have what's called the identity. But what it really means is that no matter what you put in for X, they're all going to work. Okay, so we have to try to figure out what it's going to look like when we have no solution or all real numbers. So if I want to solve 4 times x minus 5 equals 4x minus 20. Okay, the first step is always to simplify both sides. Okay, so if I just had 4 times x minus 5, I would use the distributive property, distribute the 4, and get 4x minus 20. Okay, on the other side, there's not really anything you can simplify because you can't combine like terms. So you get 4x minus 20. Okay, then I start saying, well, let me start solving. So I need to get x by itself. Okay, so I'm going to subtract 4x from both sides, right? Because I'm going to put the x's together. So 4x minus 4x is 0. Okay, and that's just minus 20. 4x minus 4x, again, cancels, and that's minus 20. Okay, so we get here, we're like, well, negative 20 equals negative 20, right? This is always true. So what that tells us is that since this is always true, all values for x are solutions. Right, so we can say all real numbers. It's a symbol for all real numbers, okay? You could say this is the identity, right? Either one works. So a statement that is always true tells us all real numbers are your solution. If I have 3x minus 9 equals 3x plus 10. Okay, again, I need to go about and solve this like I would any other equation. So I want to put my x's together, okay? I'm going to move this entire term to the other side. So the opposite of adding it is subtracting it. So I'm subtracting 3x. So 3x minus 3x is 0. So I get negative 9 on the left. 3x minus 3x is 0. So I get 10 on the right. Okay, then I look at the statement and I say, does negative 9 equal negative 10? No, this is not true. So I got a statement that's not true. It's never true. So what that tells us is that doesn't matter what I put in for x, I'm going to get no solution for my equation. Okay, so the added step in this lesson is having a variable on both sides. Okay, so the first step is to put them together on one side and then solve like you did last week. So that is lesson 3.4.